Okay, in this video we're going to do the solutions to homework 3. First question is asking for if we have a TCP packet that contains an IPv4 packet and those are inside of an Ethernet packet, what's the total size for the headers? So if we want to review what this looks like, so here was a TCP packet from Wireshark, and there we see that there's an Ethernet header, an IPv4 header, and then a TCP. This is a TCP header with 0 length. Okay, so we have something that looks like this: Ethernet, IPv4, and TCP. And this is asking for the minimum size for each. So let's look at the Ethernet first. All right, here we are in the Ethernet frame, and so we have the MAC destination, the MAC source. There's an optional part, an Ethernet type, and optional. So this is the TCP packet that's inside. Okay, so if we're looking at a layer 2 frame, then we'd have 6 bytes for the MAC, 6 bytes for the other MAC, 2 bytes for the length. That's 14. If we were looking at the layer 1, which is underneath that, it would be an additional 8 bytes. And so what I had here was 20 plus 20 plus 14, and note if including level 1 Ethernet, then plus 8 bytes for 62 total. Okay, so this is always going to be here. It's just whether we're counting it depending on. So this this information here would be read by the by the switch or the router or the computer, but then this would be the part that would actually be the data. This is just to delimit the start. Okay, next question we have, if we have a TCP packet like from the first part and we have 1440 bytes of data, what's the total number of bytes sent? That's just going to be 54 plus 1440. So we have 54 plus 1440, that's 1494. And if we look at the percentage of that that's actual data, we just divide and we get 96.39%. And so this comment here is talking about the other additional fields that actually get sent on the wire, but we're not including in the Ethernet level 2 frame. So if we look over here, there's this preamble and server frame, and then we also have a CRC check. That's a error detecting code that would add another 4 bytes, so that's 12 bytes more that are there. So if you want to include those, then you would get additional, so your percentage here would be slightly different. Let's go on to C. So now we're looking at what's the overhead. That's the point of these questions, the overhead of using these protocols. So we have a TCP connection. A TCP connection always starts with a SYN packet from the client. The server responds with a SYN plus acknowledgement, and then the client responds with an acknowledgement. So the client knows, the server knows that the client's there, the client knows that the server's there, they're all ready to go. That's 3 packets. and then the total number of bytes for those packets would be just 3 TCP packets. So each TCP packet is at least 54 bytes, and we did 3 of those. There's no data. Oftentimes there's no data in these. It's just header information with the synchronization and acknowledgement numbers. Okay, so that's 162 bytes with no data just to get synchronized. And if we're including the extra bytes from the Ethernet packet, it would be more. Alright, so now suppose that we're going to get some TCP data. So we have a single TCP data packet with 1440 bytes, and we want to know what's the total number of non-data bytes for this to be properly received. Okay, so what has to happen here is first this has to happen to get a connection, and then the data can be sent. So we have 3 header sections from the synchronization, and then we'll have the data with another header section. So we have, I'll put over here, so note what is needed is 3 TCP packets to get synchronized, 1 TCP packet with data, 1 TCP packet for an ACK. So after you send a TCP packet, for it to be properly received, whoever gets it needs to send an acknowledgement. So that's really 3 packets to get synchronized, 1 for acknowledgement, and 1 with actual data. So the overhead was these 3 plus 2 more. So we have an acknowledgement packet header, and then we have a header within the data packet. So that all adds up to 270, and if you're including the extra Ethernet fields, that would be even higher. Okay, and then if we divide, so we have 1440 bytes and 270 bytes of header information, then the total percentage of everything that was sent, this is everything that was sent, and the percentage that's actual data is only 84%. Okay, on F, this was asking to log into, use a laptop or someone else's, go to the Unix lab and see what wireless router you're connected to. And that would just be from looking in Wireshark. So here I am in the Ethernet field. I'm connected to a router that has this MAC address 0008, and it has this label Cisco Inc. because Wireshark knows that anything that starts with 0008E3 is a Cisco router. They are the ones that use that beginning code, and then this is the end of the MAC address. And then this is my computer's MAC address. Okay, so this was the router downstairs, and that's the same MAC address that I'm seeing here right now. Some people got those switched around. So the Cisco is definitely not your laptop, it's definitely the router. Okay, so that was F. All right. If we're going to, so the next one is we're going to view KennyJeff.com. We're going to look at the network traffic, see how many GET requests, how many bytes, and then we want to look at how many TCP packets that actually takes. So I want to filter to KennyJeff.com. All right, and we'll do this the way that we did it before by getting the IP address for KennyJeff.com and using that as a filter. On IP is the IPv4. Okay, so there I am. I'm going to close that tab and reload it. I don't have anything yet. Now I'm going to load. And I see nothing, so let's see. Okay, I had actually stopped. That's why I wasn't seeing anything. I want to clear this out. Clear this out. I think I want to do this, so I'm closing this capture file. All right, now I'm going to go do the wireless. That's the filter that I want. All right, that is some synchronization that's from reloading it before. I want to reload it now again. I guess let's go ahead and get rid of that. Okay, Wireshark crashed. Now we're going to go ahead and load the page. And then I want to stop. So I don't want to see any more. It's all loaded. This is in Wireshark, so I'll leave that the way it is, and let's open the developer tools. Okay, so now we'll see the number of GET requests is 2. There's one for the HTML, and there's one for the picture. And the total number of bytes is up here, 53.26 kilobytes. And that's the actual amount of data. It's going to be less than that because the picture is compressed. And then if we look over here, there's a SYN, SYNAC, and ACK. That's the 3 TCP packets to get synchronized. We have the GET coming from my computer to Kenny Jeff, and then we're going to have a bunch of information from the server. So that's these 4 here, and then every once in a while you'll see an acknowledgement from my computer to say that a certain amount of data has been received. And that goes all the way through the end here. There's one more acknowledgement after the last bit of information from the server. So I can see here there are 29 packets displayed, and those are the ones that it took to load the file. You don't want to look at the total number of packets because that was all network traffic, not just the one from this page. And you also want to stop it after loading the page, because the server will actually keep communicating just to keep the connection alive, and I don't want to count that. All right, let's see what we have for the answers there. I had 2 as the number of GET requests, and what was the question? How many GET requests? How many, let's see, how many bytes of data? Total number of TCP packets. That's on letter G. So definitely 2 GET requests for sure. The amount of data, I had here was, so 53.26 is what's actually there. That should be the total. I don't know where this is coming from. So depending on what the compression is, maybe slightly different. So that's what I had recorded from earlier. And looking at Wireshark, we had 29 packets, and that'll vary depending on whether the image is sent, yes or no. And let's see. And out of those, if we wanted to count, we could count the number of actual data packets. So that's a data packet. That is not. There's 0 length. So there's 1, 2, 3, 4, 5, 6. 7, 8, 9, 10, 11, 12. So out of the 29 packets, 12 of them are actual data. All right, we're going to do cs.indstate.edu. I want to change my filter. And start monitoring and see. And I'll keep the network view open here. Okay, so this takes a little while to load. Once it seems like it's all loaded. So this is done. Still going, all right. I'm going to go ahead and stop this. And our quick view here is that there are 108 packets in Wireshark to get this all transferred. And then I want to close it or stop it because it'll keep sending information back and forth. Over here, how many GET requests do we have? A lot. There's says 48 and it says 2 megabytes was sent. Okay, so what did I say over here? 47, okay, I had 48, 45 or 52, so that's the number of requests. Let's see, 47 requests, 2 point something megabytes, number of packets, 47, this time we got 108. Oh, these are just asking for TCP. What's the filter for TCP? So these are just TCP now. These TLS is actually, that is a TCP packet with secure socket information inside of it, so that counts. Well, depending on whether you want to. It is a TCP packet. It's a particular kind of TCP packet. Okay, so when I did this again, I got 108 packets. Total number of bytes, 43K is different than 2 megs. That'll depend on whether it's sending all the images, whether things are compressed. And there's a note here that if you look in statistics, get file properties, capture file properties, there's a summary that there's 156 kilobytes in the current file. That includes things that are not being displayed. So the amount that's being displayed is 54 kilobytes. That's definitely not 2 megabytes. So this network view here is showing the total size of all the data, and a lot of this stuff is cached, images and things. Scripts too. Okay, that's H. And then we wanted to view this. Go ahead and get rid of the TCP, keep that, and start again. All right. So the point of this is that we're downloading just one document that is a specific size. It's not going to depend on whether we're having images or whatever. Okay, that's downloaded now. I'm going to go ahead and stop the Wireshark. So while that was downloading, that's 68 packets from CS, and there were some other packets that were happening from other programs. From SSH, from Firefox with Google over here. Alright, so we were supposed to be looking at how many SYN packets, how many ACK packets, how many TCP packets. So the number of TCP packets is what I have displayed here. These are all TCP. I can do and TCP to make sure I'm only displaying TCP. There's 68. If I just want to look at ACK, let's see. Take a pause for a second. Okay, so some things that we can do here. If we have so we're looking at TCP, we can restrict to flags. So if I look at .syn not equal to 0, then those are packets where the SYN field was not 0. I have 2 of those. If I change that to ACK, there's 67, so all but one of the packets did have an ACK inside of it. Even the data fields will have an ACK if you look through here. There's an acknowledgement. So they're always including the acknowledgement of the what's been received. And if we want to look at how many had actually some data, there's 39 where the length was greater than 0. The rest of them were just synchronization and acknowledgement. Okay, so let's see what we have over here. When I ran this earlier, there was one sync, and then a synchronize finish ACK. So that's 2. When I ran it that time, there were 9, and really almost all the packets have ACK in them. And ran again, had 39 that had 0 length. Okay, and there was a note here that if we let's go ahead and take that restriction off so we see them all. A lot of times so there's finish transferring the data, and then this is the SSH traffic here, because I'm SSHing to I'm typing in here to the CS server. Right, so that's why my counts are off. All right, so let's just see what we had here. Anything time we were talking to CS, the counts are a little bit off. This was Kenny Jeff. This was CS. So this was 108 packets when loading cs.ndstate.edu and using SSH. Right, so that's why there were more packets there, because I have SSH. And really, so this, when loading the doc and using SSH. All right, so we'll take these counts as more accurate, 9 ACK just for the file, and we can see that by starting over. Let's do okay, there we are. Now I'll go ahead and do this and stop. So this is only 3 because it must have the document cached. All right, we'll leave it at that. I stopped this. Okay, so that's the homework, and the last question was just to come up with a new question. So common mistakes that people had was when you're looking at the network view, if you keep this open and I go to a new page, that's okay, but it'll keep adding up because a lot of the web pages keep asking for data. So if I want the amount just to load the page, I need to look at it soon after it loads. If you're in Wireshark, then the total, this amount down here, is as long as I've been capturing. So that'll be potentially more than just loading the page as well. It'll keep adding up. And we can see the packets going up down there. They're not packets to CS. There are other things. Okay, that's